Okay, so once you've got the platform together with the battery and the breakout connectors, the next step in the process is to figure out how to actually attach your sensors to the logger. And I do that with caps. So this is an example of one that has two wires that go through it, one with a finished connector and one that's not finished, and an indicator LED that's mounted on the outside of the housing, and that allows you to determine the logger status. So let's go through this procedure, basically building one of these sensor caps and how I do the waterproof interconnects. The first step is to take one of these PVC end caps and mount sensor wells on the top of it, and here I've got a couple already made. So this is just a ring of PVC, and this one is actually a plug connector that you can buy, commonly available at hardware stores. And we'll just put another one on there just to show you the procedure. It involves clamping, so it's not the sort of thing I can easily stick in front of the camera. Okay, but we'll just attach another one, and I use low rings like that for LEDs and flat sensor boards that I'm just mounting right on the surface, and I use these taller ones to provide a bit more support for pass-throughs. And it's not a very complicated procedure. As I said, the only trick is that it involves adding two chemicals which smell awfully bad. So this is the clear primer. So you need to prime the surfaces that you're bringing together. And then this is clear heavy-duty PVC cement. And again, you don't want to do this inside if you can avoid it. It's kind of hard for me to avoid if I'm in front of a camera here, but basically you can just press them down into place.
I'm starting to smell it.
Yeah, no, it's nasty stuff generally. So to do these kind of bonds properly, you want a clamp, and you want to clamp it in place. But at the moment, this is just for demonstration here, I'm just going to hold it. Now you can just put like books on it or any other means you've got of applying pressure, because it should really be clamped for about 30 minutes or so. It'll start to adhere pretty strongly after about a minute of just holding in place, which is what I'm doing here. I'm just going to do that, and then we'll transfer it over to the bench vise. While I'm holding this, I should mention that the cap that I'm using here, this one's got a lot of company branding and raised lettering, and all that stuff basically just interferes with the bonding of the PVC. And so I try and buy caps from companies that don't have all the logos and other cruft on the surface, because you generally want to sand that stuff off before you do the kind of bonding. So now that this is sort of half bonded, I'm just going to take it off and I'm going to put it on the bench vise. Notice that I've got them all sort of clustered on one side, and there's a reason for that, which is that on the inside, when you do the pass-through connectors, a bunch of wires come out, and if you put them all over the place, then there's no free space inside the body of the logger to accommodate other three-dimensional stuff like your logger stack. So I try and have all the pass-through connectors more or less located in the same place, so that three-dimensional space inside the housing is already sort of spoken for, and then this other space will be essentially free. Sometimes I also do other things like this. So I've reserved space for a large surface mount. In this case, it's an OLED screen. So I would still have those smaller rings arranged on one side and this on the other. I'd be very careful where I wrote the wires. Again, I still need the three-dimensional space inside the housing, but this is basically one that's sort of in progress. It's got a pass-through connector for a remote sensor. It's got a screen. This well is quite large. I'll probably be putting a BME 280, which is a combined pressure RH temperature sensor in there. So this is sort of one that's mostly through the process, and it already has some of the pass-throughs plugged and filled. Alright, so after the clamping is done, I drill a hole through each of those attached riser wells so that I can pass wires through, and then we're going to have to plug that up. So
how big of a hole do you normally drill?
I usually use the size that LEDs take. This is an LED ready to go, and most of these garden variety LEDs are 7/32 is the size. I don't know what the metric version of that is, but that just allows you to just slide the LED right into place.
Okay.
So what I'm going to do here is now I'm going to move to the next stage. After you've drilled the holes, you basically have to get the stuff in there. I'm just going to bend this over at 90 degrees. That's ready to go. And I always try and arrange them so that the wires are not in the way of whatever's inside the housing. So I try and kind of orient them so that the wires are pointed towards the outside of the housing instead of having them all sort of form a big jumble when we're done. If they go that way and bend back, I find that they just sort of get out of each other's way once they're done. So let's get some epoxy putty and seal that up. Now, epoxy putty is kind of nasty stuff as well. Almost all of this stuff is nasty, actually, now that I think about it. And I'm sure you're supposed to use gloves and all of the necessary safety precautions, which I, of course, follow religiously once a week. And the rest of the time, I forget. So I'm just going to chop a little bit off here. You don't need much, just a little bead.
What is that?
This is a hardening epoxy. It's in two parts. So there's gray in the middle and blue on the outside. And when you squish it together, you mix the two parts of the epoxy, and it forms a putty that hardens really well, but it's easy to work with. And so I use this stuff to basically plug up the holes when I have pass-throughs on my housings. So I just have to work this, and it'll get warm. If you start to feel it getting warm, you really need to work with it very quickly after that, because that means that the two epoxies have mixed completely, and
how long do you
they're going to
have
harden
after it starts to get warm?
You've only got a couple minutes, then it becomes a rock.
Oh.
So you know, I'd say maybe maximum 100 seconds, 120 seconds, 2 minutes. It works. So right now, I can feel it starting to warm just from what I was doing here. Okay. Okay, so now it's kind of nice and worked. And when I do the LEDs, I actually wrap it under the LED first, and then bring that around. And so I'm going to poke the LED through the hole, and then push this stuff back onto the housing. Now, one of the things you want to be careful about is this stuff makes fingerprints that last forever, of course, because you're hardening it into a putty. But my fingers, the ones I just used to mash the putty up, they're now covered with this blue stuff, which I'm going to wash off with isopropyl in a second. But this is basically the procedure for making a pass-through. And this procedure is the same whether it's an LED or one of those cables, you know, the sensor cables. And you just want to make sure that there's no holes for the epoxy to leak out of when you pour it in, because the stuff that you're going to put on the other side, of course, is liquid. So there's the LED, and there's the epoxy. And I try and get these flat as possible without, there's a little hole there. See that? No, I've pushed that too much, and so there's that, it would leak there. If you can see the wires, then the epoxy will leak out. So it has to be as flat as you can make it without having any visible holes. Okay, so there's a basic example of the epoxy being put in. I gotta wash my hands because I'm sure that stuff is bad. Try and get some gloves to do this stuff. It says it's got warnings all over the package for that too.
Do gloves hinder kind of making it a putty-like?
No, the reason the
Does it
reason
stick to it?
that I don't use gloves with this stuff is that it sticks to gloves better than anything else on the planet. So you're kind of torn. Like, I've washed that off of my hands now with the isopropyl, but this epoxy putty is nasty. The warnings on it scare the willies out of me. But when I try and use it with gloves, what happens is all my gloves are stuck together while I'm still trying to mash it up. The one thing I have found is sometimes if you use one of these sort of really thick plastic bags, you can kind of fold it inside of the plastic bag sometimes. And that's one way of not getting it all over your hands. But whenever I try and use gloves with this stuff, it just binds to the gloves more than anything else, and you end up having to try to scrape it off of the fingers of the gloves so that you can use it. Anyway, yeah, like everything, like that solvent for the solvent welding, it's a bit grim. Alright, so the next piece of the puzzle is the actual connector. So we need to make one of these now. So it's pretty obvious how you mount sensors right on the well, but now we need to make one of these. These little pigtails are fairly straightforward. Basically, it's just a length of wire with one of these PEX swivel connectors on it. And I use these PEX swivel connectors to make the waterproof connectors. I've described it in some detail on the blog, but let me show you a finished joint so you know where we're going here. This is just an extension cable, but it's the same basic idea as all of the remote sensor plugs that I use. The swivel connector has an O-ring, and the O-ring mates up with the same basic components. All you need is a tube in the middle and a connector between them, and you basically have the makings of a very robust underwater connector. Again, I think I published on this in 2015, but we've had these underwater for years, literally 2 to 3 year deployments, and none of them have failed so far. Now, I'm very careful about how I epoxy everything, and I extra sand these rings down to make sure there's no casting screws. So, you know, I treat them really well, but this as a form of making underwater connections or just weatherproof connections of all types, it just works really well. So let's make one. So, basic idea is we're going to add some extra soft wires. These cables, this is a PUR polyurethane cable, and it's tough as nails, but the wire that's in it is not flexible at all. And so the problem you run into is that if I took the wires from this cable into a joint, they would just break. After about 5 bends, they would no longer work. Whereas this soft, I love this sort of soft silicone stuff that I get from Adafruit. This stuff is infinitely flexible and it works perfectly in the connector. So what I have to do is basically pass the tough cable through one of the pieces and then add 4 more extra wires and then tuck all of the connections in, and then I pour epoxy inside of this thing. And that allows the soft wires you need inside of a joint, and it also gives you a break. Most people don't think about it, but there's air spaces between the wire in a wire. And so if you get a cut somewhere along this cable, even though this is really tough, it's not bulletproof, what you end up with is water running along the metal parts of your wire. And so if you put a solder join, you stop the path. The water can't run all the way through into your housing. And so it's really good practice to do this, to add some extra wires. So I'm going to zoom in a bit here so you can see me cutting this wire.
Is the wire too thick to use the strippers?
Yes, it's too tough. This stuff is really nasty, and there's no way I'd be able to just sort of pull it off. It would destroy the wire. And so what I end up having to do is carefully,
A little bit higher.
just basically cut through gently, and I'm bending as I do this so that I can expose. It's kind of hard to do because I'm farther away than I normally would be for. Some delicacy. So you see how that went through? I don't want to cut the insulation on the wires that are on the inside. Okay.
And you bend it away from where you're cutting.
I'm bending it away so that, you know, as soon as I get through it, it lets go and I can see the inside wires, because I don't want to cut the insulation on the inside. I just want to get rid of this tough sheath. Okay, so there we are. So I managed to get through that without nicking the insulation on the inside wires, and that's exactly what I was trying to do. Alright, so now we just cut and strip this stuff, and you don't want it to be too long because it's got to fit inside of one of those little connectors. Unfortunately, the inside of this wire is blue and brown. I think that's the UK standard for colors. North American standard tends to be red and black, whites, and then greens. And so I'm probably repurposing wires in a way that would not be appropriate for the country in which these are the standard colors. Okay, so I'm going to attach softer wire to each one of these, and it's easier to do this if we just hold it in a vise. And I tend to try and match colors if I can, so I'm using the red on the brown because they're close to each other, but if I can't get a close match, then I will use opposites. So I mentioned that I only use white and yellow for my I2C buses, and because there's no white and yellow, I will use blue and yellow because they're opposites. It's just, you know, everyone has their own color standards, and you always end up with these situations where you're trying to put wires of one color onto an intermediate that's another. So as long as you have a pattern, that's all that really matters, is that it's consistent.
So you said you're attaching the blue to the yellow?
I'm gonna when I use this cable for an I2C bus, it's a 4-wire cable, so it can carry UART signals or one wire or anything you want. But you have to kind of come up with an idea that, okay, the cable in the middle has blue in it and brown, and what I'm connecting to it is yellow, white, red, and black, and so you just have to be consistent. It doesn't actually matter what you choose as the pairings, just so long as you have a system that you stick to.
Okay.
The one thing that I always stick to, though, is where on the connectors the power lines are, so that it doesn't matter what type of bus I've managed to pipe over these wires, there's no way to get the power reversed, because most sensors don't care. If you hook them up to the wrong bus, they just don't work. But if the power is in the right place, they just send an error message or something like that. You know, it's a non-lethal error. But if you started reversing power,
then it can
destroy
it.
that would destroy your sensors most likely. So there's only one rule, which is always have the ground and the power on the same part, you know, the same location. Okay. So these are the wires that will be, these soft flexible ones will be inside the connector joint. And these are now plugged so that if for some reason water was coming inside the cable and trying to run along, it would hit the solder joint and have to stop because there's no longer a continuous path. Trim these to length just to get rid of the excess. And then I'll put some heat shrink on these. And this is just so they don't touch each other once I stuff them into the connector. Okay, just fold this up. Alright. Now, at this point, I'm just going to slide the connector along, but before I do that, the inside of these little PEX swivel adapters is super smooth, and epoxy really doesn't like bonding to smooth plastic. And so what I'm going to do is I'm going to tap out the inside so that when the epoxy hardens, it's got a ridged surface, and that allows it to form a strong bond, even though it would normally not bond to this plastic. So this is just a standard tap. Actually, what size is this one here? 8. It says 8 times 126. I have no idea what that even means. Anyway, it's the right size for these, and you probably have to bring one in and go hunting. But
is it just slightly bigger than it?
It's not even really bigger. It's just that it has these teeth, and those teeth will basically wear their way in. Actually, I'm gonna need a wrench for this. Oh, maybe not. But what I'm doing is this creates rifling on the inside, and when the epoxy sets, it sets into the grooves that I'm now creating. And so, oops. Yeah, I need a better pair of pliers to hold this. See the silver ones straight ahead there? Yeah, perfect. These are channel locks. By the way, best pliers ever invented. If you ever buy a pair of pliers, try and get these are called channel locks because you can make the opening different sizes based on that channel.
Oh, and lock it in.
Yeah, and so they're one of my favorite tools for stuff like this. Alright, so there we are. Now I'm just finishing the tap. And I'm going to pull this off camera because it's now shedding a whole bunch of particles as I undo it. And I'm not sure we'll be able to get this. I'll try and zoom in on it and see if it'll work, but I suspect it's just too dark. I don't know if that's showing up or not, but there's now a thread carved inside of that adapter, and so the epoxy will fill into that and it won't come out no matter what. So that's basically the idea. So we've rifled the adapter, and we just thread it on here. And, I try and bunch all those little connectors onto one side, and the reason I do that is that you want some air gaps. So right now, the way we've got this set up, all those little connectors are on one side, and there's an air gap there and an air gap there. And when we pour the epoxy in to seal this, to really make this connector robust, it flows down those air gaps. Okay, so now I'm pulling the cable in. And again, probably won't show up on camera, but I'm going to pull this so that those joins are about in the middle of the tube. So there's room at the bottom for epoxy, and there's plenty of room at the top for epoxy. Okay, so that's my one part of my interconnect. But if I just poured epoxy in there now, it would just leak out the bottom. So what I have to do is seal it somehow, and you do that with some heat shrink. So this is double wall adhesive lined heat shrink, and if we slide that over the pigtail.
Is that different than normal heat shrink?
Yes, it's much tougher, and it's got melted glue on the inside. It's got hot melt glue in there. So when I put it up over the edge of the connector, all I want to do really is form a cork, but this also is strong enough to provide a lot of support. So now I melt the heat shrink, and it's adhesive on the inside around the bottom of the connector, and it takes a minute or so to do this. Alright, now it's a little crooked, so while it's still warm, I straighten it up. And so now I'm putting some tension on there, and I'm just going to roll this to make sure there's no air bubbles so that the adhesive is forming a nice solid join. And then you have to blow on it for a little while because it really hardens up once it's cool. I've got some real tension on this while I'm blowing on it to pull it off so that we get a straight through. Alright, and once it's cool, that stuff's really tough, and that's the adhesive that sort of leaked a little bit at the bottom. But now we have a cork, and we can pour epoxy into that. So I basically just mount this guy in a vise, and with my epoxy gun, I'll slowly add epoxy in there and fill it up. And you have to go in with a pin and poke around those two holes and just make sure all the epoxy makes it all the way through into the bottom of the connector. Bubbles will come out. It takes about 2 hours for the whole procedure. So you fill some in, and then it sinks down, and you put some more in, it'll sink down, and then a bubble will come up, and you poke the bubble and you pour some in. So, you know, once you start the epoxy pour into this little connector end, you know, be ready for every half hour over the next couple of hours, be ready to come and put a little more in or poke some bubbles if you want to make it absolutely perfect. The only thing that really matters is that the epoxy gets around those solder joins and fills the bottom of the cup. It doesn't always have to be right to the top here. Okay, so once the epoxy's on there,
You said you wait 5 days before you deploy it, at least?
that's for stuff where the epoxy is exposed directly to the sensors.
Okay.
But in this case, because it's inside of a piece of plastic, also wrapped in heat shrink, you could probably deploy these connectors within 2 days, I would say.
Okay.
24 hours would be the minimum I would give the epoxy I'm using, which is E30CL. That's this stuff. We've had a lot of luck with this over the years. It's stood up to marine exposure quite well, and I like the fact that it's clear because it lets you see LEDs and things like that through it. And we apply it with a gun. It looks like this. But you can get these guns pretty much anywhere on eBay. They're not that expensive. So there's $10 versions of this gun that I've linked from the parts. If you go to the classroom section on the website, you'll see a link to the affordable version. So these are about $12 to $15 for the epoxy. It's not very much, it's only 50 mils, but it works. And you can buy these for about 10 or 15 bucks as well. And you have to spend more time actually worrying about these nozzles. This is a 21 element nozzle, and I tried some shorter ones and they didn't mix the epoxy well enough, so you kind of need to get this one. Again, it's linked to multiple places on the website, but this is a 21 baffle nozzle for this Loctite E30CL.
You said it mixes it 2 to 1. Or 1.
That epoxy is a 2-to-1 mix.
Okay.
And that's probably why it's a 30-minute epoxy. You can buy the same stuff in 5-minute, 10-minute, various shorter ones, and I think it's the ratio of hardener that you put in. So once that's filled, and I think I have one here, let's do the cooking show trick. Here we are. Let's see if I can, I don't know if I can really get in there. Again, this is tiny stuff, but once it's filled, it's going to focus on that. You can see there's a little bit of stiffness there where the residue, but the epoxy itself has filled the pot further down. If I poke this in here, it's hitting all the epoxy. So the epoxy is now all in there. This is just a little bit of residue left on the top. But this thing's solid full now. And once it's solid and filled, you route the thread over it. And this is really important that you don't forget to put the threaded part on there, because it's easy to forget when you make these and then you try and mount them to a housing and you realize you've forgotten the thread ring. The other thing that's easy to forget is the washer. These only work with a cone washer, so you have to take the cone washer off to do the epoxy job because you don't want to ruin your washer, but it's easy to forget and not put it back on. Okay, so there's the cone washer back on, and usually you have to kind of pull this to get past the heat shrink. And then the next step is to put a connector on. So the question is, how much wire do you leave? Well, to know how much wire you need to have the intermediate part in the middle, because the idea is no matter what length this is, and you can buy these in this whole system's available in different diameters and different lengths. It's just, these are just parts from Menard's plumbing department. You want to make sure that you don't cut your wires so short that you can't hold onto the connector when you're putting it together. So basically, the idea is you pull it through your joining part, however long you decided to make it. This is a 2-inch. You pull it through and you cut it so that you can always reach the connector on the other side of the joiner. Okay, so that's how I set the length of where I cut. And now we put a connector on. So same as before, I'm using Dean's connectors. Again, if this was a pass-through coming from a housing top, this would be delivering power to the sensor, which is the next stage, and so this side will be the female side. You want to make sure you don't get your genders mixed up in your pass-through connectors. We went through this in some detail on the last one, so I'm not gonna worry about making the connectors, but it's pretty straightforward what you're doing here. You just put some heat shrink on there and you join those up, and you end up with a connector like that on one side, and then you use the same methodology to make another connector for the other side. Put your tube in the middle. Okay, and you want to make sure you're not pinching any wires. So you put the rubber over it. Tighten one side. Make you connect. Gently pass that in. And I find that slightly longer actually helps because the wire folds. But you want to fold the wire in and be very careful that you're not pinching any wires on the other side. Okay, so we're basically just going to make a smooth connect there. And there's our connector. So there would be a sensor on one side and the other side goes back to the housing. Okay, so a few moments ago we added epoxy to this, and it's now hard as a rock, so we could basically start pouring epoxy. And in a cooking show trick, I have one here that I did last night. So here's one where the epoxy's been poured into that well and has hardened up. So you can see that it's slightly cloudy. That epoxy is not perfect because we don't have a vacuum chamber. Basically, when you use that kind of epoxy industrially, you're supposed to pour it in and then you evacuate it so that all the bubbles come out. And since I didn't do that, the bubbles are still in there. So it's slightly cloudy, but it makes a really nice waterproof seal. Again, the combination of the epoxy on the inside and this on the outside, it's bulletproof at that point. And then the next step would be to take that connector we just made, and just as we added the wires on this side, we'd be basically adding another set of wires to go through. So let's do that. Essentially, it's just a replication of the procedure we just did. Attaching softer, more flexible wires, and then when those wires are attached, we thread the soft wires through the holes in the housing that we just produced, so that the hard wire and everything ends up in this pot. Okay, so we run it through just like we did the LED. The soft wires come through the housing, you plug the hole with the epoxy putty, and then we fill in this little well, and I have some of those ready here.
Is the hole not big enough to fit the large wire?
You could, yeah,
Okay.
that would go through no problem, but you don't want to do that. You want to have a break in the wire. Remember, water can travel along these cables.
So
Because the cable is a bundle of little wires together, and if you think about how circles pack together, there's always airspace in between them.
Yeah.
So if I ran this right through the housing, like completely, and we got a cut in the wire underwater, there, the water would go into the wires of the cable, run along the air spaces of the wire, and then it would go right into my logger. So you want to break the path somewhere. So that's
it's minimal damage.
It's minimal damage. Also, the wires that are inside this cable have terrible flexibility. They would probably break really quickly if we passed them all the way through. And that's why I add the soft interconnects. These guys are these have no problem flexing. They're not going to break. They're really nice. You know, they have a silicon jacket, whereas this is all polyurethane, very stiff. This is a 7-stranded wire inside. I think these have 30 strands inside them.
Oh wow.
So they're super flexible. And then once you've got your pass-throughs done, you just add the connector. And again, keeping with our philosophy of the side that has the power should be female, this is the cap. The cap is taking power from the logger, so this end's got the male.
Yeah.
And at the other side, it's female, because at the other end, it's the one giving power to the sensor. Right. Okay, so this is sort of all the different steps. LED pass through with the putty, and then you add a connector. The wire, you add jumpers to go through the housing. Wherever you put the hole, pot the hole with epoxy putty, and then you can fill with liquid epoxy, and these were done last night. You can see, I don't know, let's try and get a close-up of this, if you can see the connections inside the epoxy here. You might not have enough light for this, but
Oh, you can see it, yeah.
I know you and I can see it, but I'm not sure how well it shows up on camera there. But all those solder joints are now embedded in the epoxy, and what that means is that there's no path for water to go through the cable into the housing.
Okay.
Okay, so that's the basic idea of the sensor housing. Now, in your case, it's a little unusual that we're going to be using both of these pass-throughs for I2C sensors, because you want isolation on your EC sensor from Atlas.
Yeah.
But if normally I would only pass one wire through for the I2C bus, because it's a bus. You can hook as many sensors, well, I think 128 for I2C, as you want. And then this other line would be for some other type of sensor, like a one wire, or in the case of the one with the screen, usually I have a combined pressure RH temperature sensor there, and then this guy goes through to a tipping bucket rain gauge. Yeah, actually, why don't we take a look at that? That gauge right there. Oh, we're going to have to widen out the screen here a bit, I think. So anyway, this is sort of a standard tipping bucket rain gauge. And because this is just the generic 4-wire pass-through, there's nothing in this method that has anything specific to whatever's going on with the wires. What I do with the rain gauge is I only use 2 of the wires, because there's a relay. When this thing, when the rain falls in, it tips and triggers a relay.
Okay.
And so I actually carry back an interrupt signal, so that this line here goes high or low depending on the state of the relay inside the rain gauge. And then inside the logger, the connector takes the blue line to one of the interrupt pins on the logger. So it doesn't use the white line at all, and it doesn't use the red line. It's basically it's just making a connection.
Either on or off.
But I do have a little dead bug circuit there inside the connector. So this is the connector from the rain gauge, and if you can see, there's some resistors and a capacitor. And that's what gives the rising falling signal. When the relay closes inside the rain gauge, the resistors and capacitor bridge just basically forms the high-low signal that goes back along the blue line. So these wires can carry basically anything. You know, you don't have to use all the wires. Here I'm only using 2 of them. It's a very generic method of doing pass-throughs for the housing. In this case, it was just carrying an interrupt. I slightly modified this idea of this underwater connector and this pass-through method to mount sensors. So let's take a look at one of those. Alright, so at one end we have our familiar connector, just as I would use for a pass-through, and that's because this is actually going to connect to a housing through one of those connectors. So this is, in this case, these wires will be an I2C bus, because what we have at the other end, this is about a 3-meter cable. At the other end we have a pressure sensor. This is an MS5803, and I like mounting them inside of these little cups because it's just one integral piece, and it's just an easy way of getting the epoxy around them. Now this one was cast last night, and it has a flaw in it. Let's see if we can show you that. I'll have to recast this. Well, not recast it, I'll have to fill it in. You can zoom in a bit there. There we are. Okay, stop. So there's a bubble. I don't know if you can see the way that's reflecting, but there's a bubble that rose to the surface out of the epoxy. And so I'm going to have to poke that with a pin and pour more epoxy in. The other thing is probably hard to see at this angle is that there's now a slight concavity there. The epoxy changes its volume. It actually shrinks. Not only does air bubble out from the base of the connector, but you also end up with sort of a compression because the epoxy itself contracts. And there's really not a whole lot of epoxy over that circuit board, right? I mean, the depth at this point of this epoxy is probably only a millimeter or so, and it's become slightly rounded because of the compression. So what I'm going to do tonight is I'll poke that with a pin, and I'll add very carefully a few more drops of epoxy just to thicken up that layer. So this has been setting for 24 hours. It's probably good to add the next layer now. So I'm going to have to add some more epoxy to that one. But the reason I like this type of mounting of a sensor on the end of the cable is that this is the mate to this system. This is a PEX plumbing part. And the female side has a rubber cone washer. Again, this is just a larger version of this. Those are essentially identical parts, only this is the half-inch part, this is the 3/4 inch part. But in this case, I use the 3/4 inch solid male part, and then this gives me a protection method over the top of the pressure sensors, because the pressure sensors are quite delicate. That exposed white spot can be damaged easily, and with a hole in the end, I can run a zip tie through this, and that gives me a way to anchor the pressure sensor. So I can basically tie this off wherever I want the sensor to be located, and it'll hold it in place, like on a rock or in a stream. You know, almost always these are being deployed underwater. The MS5803s are not rated for long water exposures, but we've had them working for years. So, slightly modified for the connector part, and you have a way of mounting the sensors. So let's do that. Let's put a sensor into one end of the cable here, and we'll see how that looks. Alright, so there's one of the pressure sensors. Sort of the raw version is just the metal cup and the little white and blue board there, and I've mounted those onto, I think it's an SOC8, I can't remember the name of this little expansion board. And there's a capacitor and a resistor for pull-up. It basically sets it to I2C mode in the address. So once you've got the sensor in that state, you can test it, make sure it's working, and we're basically going to replicate what we were doing to make the connector pass through, only this time when we put the cup on, we're just going to seal it up, and there won't be extra wires coming out, but it'll be the same basic method. Now this is a silicone cable. This one's much softer and more flexible, but the wire inside is not much more durable, so unfortunately
A little bit higher.
this one doesn't really doesn't give us anything. I wish that I could find the right wire which would have the silicone jacket and the multi-strand. See how easy that came apart?
Yeah.
I didn't even have to cut it. That's because this is a silicone cable. Unfortunately, that also means it's delicate. So we've busted most of our silicone cable.
Do you ever lose
sensor
sensors
strings.
while they're deployed because they get cut by some rock or
No.
something?
We lose sensors because they get caught by people. So basically, anything that can walk away, it will grow legs and walk away. We've lost several off of reefs due to hurricanes, but that's a different thing. That's when the reef is coming apart too.
Yeah.
So yeah, we've lost several, but I don't think it was because of the integral strength of the wires. Most of those, the base plates were torn away.
Oh, what?
And so, you can forgive it for being torn off during a hurricane down in the tropics. It just happens. And the ocean folks lose stuff all the time, and they have a system of identifications so they can find their lost equipment when it drifts ashore 2 years later.
Oh.
It's not that uncommon.
Wow.
Right? A storm out in the tropics is a pretty impressive thing.
Mm-hmm.
Okay, so I'm going to trim this down quite short because I want it to go inside of that cup.
But this is the same method and everything that you've done in the couple
Yep.
ones preceding it.
Yep. So, but that's, you know, I don't want it to extend too far, so I'm really cutting these guys down. There's something about the red, it just doesn't strip very well. Okay, and again, my system is either the color matches closely enough, like the red and brown, or it is complementary, so it's the opposite, so I always put the yellow and the blue.
So with this one you connect the yellow to the blue because the rest more or less match up?
Yeah, the red and the brown are close enough. The white and the black obviously match fine, and so I just use yellow and blue. And again, that's just a pattern that I follow. It doesn't matter which ones you decide to do, just so long as you're consistent. So for me it's either close or complementary is the rule. So orange and red are close. So if I had an orange wire, I'll sometimes repurpose that as the red wire just because they're close.
How far past the joined wires do you go with the heat shrink?
Normally I would go farther. This one's probably about the right length. That's about half and half. But in this case, the only purpose of the heat shrink is to protect them from contacting each other inside that little connector. So those are going to get folded down like that, and then we're going to slide the connector over the end. Now this is a 3-meter cable, so I'm going to take a moment here to do that. And before I do that, once again, remember how smooth these are on the inside. So I'm going to do exactly the same trick we did before, which is to tap it out so that the epoxy has something to stick to. It's easier to hold this one because it's a slightly larger connector. This is a 3/4. Okay. This one's a little bit trickier because you have to sort of work these into place. They won't go into place naturally, so you need to use your tweezers to sort of convince them to go into the connector. Just try and squish them a bit here so they hold together. Slowly pull that in. And work them into position. Sometimes you get lucky and they'll just slide right in. Most times not.
What do you mean in position? Into the...
They have to go into the body of the connector. There we are. So, whoops. I had it. Okay.
And do you still want them all on one side?
Yes, because the same principle applies. When we put the epoxy in, what I really want is for the epoxy to make it down into this area here, because this is where the seal is, right? I mean, if water's going to come in, it's going to come in here, and there's our solder joints, and I want this area full of epoxy. So I've pulled it down, and as you can see, it's a little crooked. That's pretty normal, but it's on wire, so you can kind of just sort of push it into place. I'm not going to position that too much yet because we haven't heat shrunk them into place. So now I just
And the board with the pressure transducer, you don't want that to be sitting against the hole?
No, I want there to be lots of room to let the bubbles out. When we
Okay.
pour the epoxy in, I want the epoxy to run around the wires first, and then we'll fill it up to the surface of the board. So I wouldn't want to jam up the hole with the board, because then the bubbles wouldn't escape.
Mm-hmm.
So again, when you use that applicator with the mixing nozzle, you're usually adding like a drop or two of epoxy at a time, and it's got the consistency of honey to give you a sense of how slow it moves when you're putting it in. So it's like, yeah, you have to be pretty zen about it. It takes 2 hours. I usually do a batch of like 10 sensors at a time, because then by the time I'm finished sort of poking and prodding, when you do a batch of them, it doesn't matter how long it takes. You're working the whole time.
Mm-hmm.
Okay, so that's pretty hot. I'm just going to burn my fingers. But as before, I'm just going to put a little tension on the cable and let that cool. And I gave that a little bit of a squeeze to make sure that the marine adhesive is sealed all the way around the wire. And it's hardening up now. Okay, so now that provides also some bend resistance. My sensor's a little off kilter here, but it doesn't really matter. I mean, as long as it's inside here, we can tilt it and bend it just until it's perfectly level, and then I'd be supporting it in a vise overnight of some sort. My little pan of ice here can stand in for that. So, and that would hold it level, and you would basically just poke the wires. You see how much that shifts? You can really do a lot to level it, so that when you put the epoxy in, even if the sensor was sideways, even if the sensor was at 45 degrees, all you would have to do is basically hold the pot at 45 degrees. The only thing that matters is that the epoxy comes up and covers that board and is level with the white sensor part. So even if you can't quite get it straight, you can pour the epoxy so that it ends up at whatever angle it is necessary to give you the most coverage on that board. So that is basically a sensor attachment. You've got a challenge in that your sensor is quite large, right? So these parts only go up to 1 inch, and they're really expensive when you get to larger sizes. So we have 2 parts for your sensor, which is the Atlas board plus the EC probe. And so we had to come up with another method to make a bigger pot, basically, to mount the sensors in. So the idea is that we're going to make an equivalent to this part, which is an off-the-shelf part, but we're going to fabricate it out of separate pieces, and we're going to put them together. So this is just, these are cheap cable glands. I think they're 25 cents on eBay. I wouldn't even use these normally, except that we're going to be filling it with epoxy anyway, so whether or not it's a good cable gland doesn't matter so much. It's just there to plug the hole. And then this is just a PVC cup. And instead of using, this is a slip fit cup that you would just put a pipe in and glue. Alright, so if we start with one of these, and we drill a hole that's close to the size that we need into it, then we can tap it. Now I'm just going to change the bed on my tap here. So this one, I think it's a 12 millimeter. Yeah, 12 millimeter. So this is a 12 millimeter tap, and this is a PG7 size cable gland. And if I tap that just right, I'll be able to thread this right into the bottom of the cap. It's not hard to do. Again, these are really soft materials, and so They tap well. It's hard to get started.
So normally you do this with metals, not PVC.
Yeah, this whole tap set is usually for putting threads into metals that you've drilled, and so you'd be doing this in aluminum. So they cut really well through soft stuff like this PVC. I'm gonna just pull that back so I can do it with the garbage can here. Okay, so there's the hole that I've tapped in, and again, if I get the size correct, this one's pretty close. It's actually tightening up, which means it's not an exact match between those threads, obviously, but it's close enough in this case. And if I did some homework, I could probably find a perfect match. There we are. Okay. So. Alright. So that is a 1-inch diameter version of that, basically. Only in this case, we don't even need to use the marine heat shrink to make the seal, because as you tighten this up around the cable, let's put some through. So basically your cable goes through. Let's loosen that up a bit. You make the join just as we did before, only when you're ready to make the seal, you tighten the cable gland down and it squeezes a rubber O-ring around the bottom of the cable.
Oh wow.
Okay, so that's going to be our potting cup, and you could do basically anything you wanted, only in this case you've got a long sensor. Do we have that kicking around? Alright, so this is an example of what we were just talking about. So I've got the cup and the cable gland, and what we've done, this is just sort of the temporary version for testing, but I'll loosen the gland here and just unscrew. This is an Atlas Scientific EC probe, and what we've done is, for the purpose of testing, we have the controller board wired directly to the sensor. I'm sure this violates their warranty, but basically it's just held together temporarily with some heat shrink tubing, and you can see the cable going through the gland. And so for now, this little so there's enough depth that we can pot the sensor, and we can also see the indicator LED. We've got it set up, the indicator LED is on the corner of that board, so it's still going to be visible once it's finally potted. So a controller board, sensor, and a way of connecting it to our standard cable. And this idea can be replicated at any size. Once it's past testing, then we get out the epoxy and we just pot the whole thing in. And for transport or hooking it up to a different system, again, it's a threaded connector. We can just add it to as many more pieces as we need, either for protection or for T-junctions, for flow cells, however we want to modify it. Once you've got a thread to work with, you can add pieces as needed. But for now, this is now ready for testing stage, and then potting after it passes all its tests.